doing research and public ethics. We are in the 11th class of this, 11th lecture. And what we do every day, we define क्या कर रहे हैं हम लोग, what we are doing, we are studying all these things. So green part is already covered, so we have completed research design. So we'll start from collection of data. So what it is basically. So we will do a recap as we do again every day. So here, what we have done is we are going through the research stages. As we discussed that there are around 11 research stages which we follow one after the other, and it's not that there is a hardcore boundary between them. So we go back and forth, and in every stage we learn everything till last breath. We'll continue to learn something. That is the thing. And research problem, we define research problem, and the techniques. We have discussed a lot about this. Every day we have revised. Then we have done revise what is survey of literature. Everything we have been discussing all these things. So problem, again, 5 techniques by which you can define the problem, and how we will do the survey, and what is the benefits of survey, purpose of literature survey, that we discussed. We discussed how we will write a literature review. We also discussed that. And then we defined what is the hypothesis, research hypothesis. So it's basically an assumption, and how we will define your research hypothesis, that also we define that. Okay, if we have a problem and literature survey, what we'll do, we'll discussion with the colleagues, we'll examine and data, means review of similar studies and personal investigation. All this we will do and propose a hypothesis. We discuss what is the difference between research question and research hypothesis, and then we went to research design. We did around 3-4 classes on research design, the most important part of research. But you cannot define one is most important. From problem to your structure, everything, report making is important. So this is what we decided. What is a design? The preparation of design is research design. We answer certain questions, and basically it's a blueprint, it's a plan of your research. Okay, it comes from the name. Why it is needed? Because it is required. It increases the efficiency of your research. You better manage your time for your hypothesis testing. It minimizes any bias and errors. It provides reliability and proper direction to your research. So these are the advantages or the need what is for the research design. Then we understand what is the characteristics, and then we discuss the 10 questions and also the 10 criteria, or the concepts of research design, the terms which we have discussed in details, lot of time, many. That is, what are independent and dependent variables? What we do, we generally a hypothesis is a relationship between the independent variable and the dependent variable. Okay, the research hypothesis, testable prediction linking these two variables, and so you will test it. So the hypothesis contains these two variables, but there are other variables, which is not there in the hypothesis, that also affects the dependent variable. And if you are not careful enough, we will make a error in the testing this prediction. Okay, so to remove this error, you have to identify the extraneous variables, that is the independent variable which affects the dependent variable, not the independent variable of your concern. Okay, so it's a different variable, and we termed it extraneous variable. So what is control? To neutralize the extraneous variable. So you have to always do control experiments. When you are doing experiments, you have to see that other factors other than your independent variable is not affecting your dependent variable. So this is what is control. But if you fail to do a control experiment, what you will land up with? You will land up in a confounded relationship. That is, you will land up in a dependent variable which has been affected by the extraneous variable. Okay, so occurs when an extraneous variable influences both independent variable and dependent variable. Experiment. So you are doing a hypothesis testing research. You can do it via experiments, or you can do via other observations, other techniques. Okay, so when we do it with the help of experiment, we call it experimental hypothesis testing research, and when we do it without experiment, we call it non-experimental hypothesis testing research. Okay, experiment for experimental hypothesis testing research, we need two groups generally. One is the experimental group and one is the control group. What is the experimental group? Which receives the special treatment or manipulation. A control group which does not receive the treatment. And what is treatment? These are the specific intervention or special condition applied to this experimental group. So there are two groups. This is needed for the research design. Okay. And experiment, it's a structure study where treatments are applied and effects are measured. An experiment is a smallest unit where the treatment is applied. And we did lot of experiments on research design, realistic experiments, also the agricultural one, which are there in the syllabus. Okay. So these are the things where informal experimental design and formal experimental design. So informal experimental design are of three types. Okay. What are those? We define those. Okay. What are those experimental designs? First is informal design. First is before and after without control design. So we have all without control, only experimental test area, no control area. Right? We do not have a control area where we are testing the usual condition and eliminating the extraneous problems. Okay. So here only one area is selected. The phenomena is measured before and after. So that is from where the name comes, before and after without control design. So the treatment effect, the relationship is the treatment effect, means fertilizer in case of agriculture, and the output of crop output is the dependent variable in case of agriculture. So the treatment effect is related, independent variable treatment effect is related to the dependent variable by this fashion, y minus x, means after the treatment and before the treatment. This is the treatment effect. We establish the relationship, or the hypothesis testing is done, and you come out with the output. But that output is susceptible to extraneous variations like passage of time, as well as control areas are not there. Okay. So for removing that, after only with control design is introduced, where there are two areas, but you measure only the effect after your treatment in both of them. Okay. And the treatment effect is equated to this. So here the extraneous variable, non-capability of the test and control area. So the two lands can have different initial fertility. So the passage of time effect is removed, but the initial fertility is not to account. So for removing that, you have to do before and after with control design. So we have a test area and control area, and you have to do the before and after treatment measurements. No extraneous variation with the passage of time and non-capability of test and control area. So both are removed here. So the first one, the before and after without control design, is the easiest thing to do. Simplest thing to start with, but it will be weakest in terms of extraneous effects. Okay. But after only with control is stronger. But again, the initial differences may bias the results. We told that research design is important to remove biases and improve the reliability. So it will have biases. But before and after with control design is the strongest among these informal design, as it accounts for both baseline differences, means the soil fertility at the initial case, and the treatment effects, means during the treatment effect, if there is the variation in rainfall, that also will be taken into account. So all these three we learned in details with examples. Today I just told you in short. And then before coming into formal designs, the formal designs, these formal after these formal design, we learn two techniques, which is the principle of replication and principle of randomization. Replication is simple repeating. Random, it comes from the name, it is random selection. Okay. So there, then we did the CRD. CRD is completely randomized design. And the first among the formal designs. In the formal designs, the agricultural design, formal design, first is the CRD, completely randomized design. So there are two types, a two-group simple randomized design and a random replication design. We studied these in details. A random assignment of the items to two groups is technically defined as the principle of randomization. Experimental and control area, both are there, okay, are randomly selected. So experimental and control area are randomly selected. There is no bias in selection. Randomly you select the plots. If you have 12 plots, you randomly select any plot. One you susceptible to fertilizer and the other to not to fertilizer. Okay. And then you measure the effect of fertilizer. So experiment and control groups are randomly selected, and treatments are assigned randomly to experimental units. So you selection, we do not keep any bias in selection. We do a random selection of the plots and also a random application of the fertilizer to the plot. Okay, the units, the control units and the bias units are randomly selected. But in a random replication, how it is different from this? We do a repetition as well. Here there are two only, okay, 1 and 2, but here there are multiple. Okay, so what you do, a random replication design is essentially completely randomized design with multiple replications of these two treatments. So here's these two treatments. If you do multiple times, then it becomes a two group. Instead of a two group, it becomes a random replication design. So there is not an experimental and control group, but there are multiple groups. Okay, and in the experiment and control group, it was randomly selected. Here also it is randomly done in the multiple groups. Then we went into randomized block design. Improvement over the previous design, the CR design. We are discussing the formal now. Informal is over. So in the formal, we had discussed, we had 4 points. 4.1, the CR design, that is the first one. Completely randomized design. Those are of two types we discussed in the previous page. And now we discussed in details what are randomized block design. So it's just blocking. Means in your plot, you create the agriculture blocks, you create blocks. And you assume that in RB design, subjects are first divided into groups known as blocks, such that within each group, the subjects are relatively homogeneous with respect to some selected variable. So we assume that within those blocks, the fertility is uniform. So that is my assumption that we are doing. So we have to select the blocks in such a way. So this is a randomized design. The main feature is that each treatment appears the same number of times in each block. So in each block, each treatment will appear in same number of times. We did it with a row and column last day. And we saw that in one row, only each treatment is appearing only once. But in the column, it can appear many times. But in lattice square design, it's a square type. Okay, equal number of rows and columns. Why? Because it is an experiment design which vary frequently using agriculture research, and experiment has to be made through which effects of 5 different varieties of fertilizer on the yield of certain crop is to be judged. In such a case, the varying fertility of the soil in different blocks in which the experiment has to be performed must be taken into consideration, and there may be an impact of varying seeds to the yield. To overcome such difficulty, means the soil fertility and the seed weighted, the LS design is used where there are two major extraneous factors such as the soil fertility, varying seed, we are removed. Okay, no treatment occurs more than once in any row or any one column. So here it's a square one which we come into play. All these are one factor designs, means you can decide the dependent variable based on only one independent variable. Say if you do it with fertilizer, you can do it with fertilizer. If you do it with seed variety, you can do it with seed variety. If you do with crop variety, it's based on crop variety. Only one independent variable effect on the dependent variable is evaluated by these techniques in these designs. But in a factorial design, multiple are done. So in simple factorial design, we studied in details again with the help of column that it's a two-factor design. So two factors will be considered, and complex factorial design will take into account multiple independent variables. So these are very complex. So simple designs we took. In case of simple factorial design, we consider the effects of two factors. So now you can fertilizer as well as irrigation effect. We did with example, if you remember, these two factors on the dependent variable, that is the out we studied. But when an experiment is done with more than two factors, we use complex factorial design. Simple factorial design is also termed as two factorial design. Okay, all these are one factor design, whereas complex factorial design is known as multifactorial design. Simple factorial design may be either 2 by 2 simple factorial design, or it may be 3 by 4, 5 by 3. So we did a 4 by 3 example, if you remember last day. If you go to the previous slides, you will then understand. So then we went into sampling, sample design. So we studied only what are the characteristics of a good sample design. So what are the good, what you will tell as a good way of selecting the samples. What those are the characteristics are: sample design must result in a true representative sample. So we will select only 5 samples, but it can be correlated with the universe, means the whole sample. Okay. Second, sample design must be such that which results in small sampling error. The error should be minimum. Sample design should be in such a way that it will take care of the funds availability. How many sample you can, how much in your rack you have the chemical. You have chemical for only 3 samples, you can prepare 3. So all these comes into play. Sample design must be such that the systematic bias can be controlled in a better way. But if those 3 gives you bias, we have to buy and purchase and do more. So that all these criteria, means the availability of funds, infrastructure, the good research design, all this will come into play when you design a good sample design, so that whatever output or the relationship you derive by hypothesis testing between an independent variable and dependent variable, it will depend on the number of samples. it should be universally true. It should not be that, okay, it is true only for my sample. It should be extrapolated. Okay, sample design is such that the systematic bias can be controlled. Sample should be such that the results of the sample study can be applied in general for the universe with reasonable level of confidence. Okay, we can say with confidence, okay, between that concentration, this will be the result. So I say, suppose if you have evaluated 1%, 2%, 3%, 4%, 5% of doping in one sample, you will be able to say, okay, between 1 to 5%, if I take 1.5, 2.5, 3.5, 4.5, the effects will be similar. According to my plot, it will be similar. Analytical chemistry, those who have done, you know that, okay, within that, the same line we can draw. So if we plot, so Lambert's Beer's law we did, we do initially a calibration curve, right? So there, what we do in that calibration curve, we select the sample, we select the concentration here and plot the intensity, right? And the sample concentration versus intensity, we draw a straight line, and we call that this is the calibration curve, and the unknown you fit here, there. Okay, now suppose we have done concentration effect of 1 to 5%, so we can fairly say the my calibration curve to from 1 to 5%, anything between 1 to 5 I can put it there. So it is universally true between 1 to 5%. I'm not telling it will be true for 10%. 10% to extrapolate karke, if you plot it there can be errors, because again we assumed in Lambert's-Beer's law that the interaction between the analytes is minimum. Okay, so it is true for very low concentration. If we go to very high concentration, we can have errors. So those errors might creep in. So we have to think that there should not be sampling error. So this is how the sampling has to be decided. It is very true for every research, very much for analytical research, because in analysis you have to decide, okay, this is the my concentration of the sample. Within this reach, my sample has to fall, and I can fairly predict that it is universally true in this region of analysis. So this is all we have done till now. And then we discussed what are the differences between hypothesis, law, theory, facts. Okay. We discussed. Okay, so what we did is that initially you are proposing a research hypothesis. What you are doing in a research, that you are testing it with the help of data. You are doing experiments or theoretical research, and you are creating data, and you are coming to fact because you have repeated those. And if you say an observation of by data collection, you are getting the same observation, then you can fairly with confidence say that, okay, it is a fact, it is happening. Okay, and you reach the conclusion. Several such hypotheses and several such data, several such facts, you complete your thesis. But see, it's better if those all can be correlated. If not a law, you can derive a principle or a better conclusion or a theory. Like we discussed that the kinetic, it's broader, is the kinetic theory of gases, and there are Boyle's law, Charles' law, and before this they have not gone backwards. Initially, how they have started, pressure is inversely proportional to volume. From there they have started, and they have created the data, and they have factualized that, and then come to the law. And several such law, Boyle's law, Charles' law, and all those things, Van der Waals law, and then you come into a theory. Propose the theory of how the gases interact among themselves. Like that, we discussed in class last day about the gravitational thing. If we throw a ball, if you just drop a ball, or if you drop this, it will fall down. We are repeating it, it is becoming fact. Okay, it will fall down. But why it is fall down? It comes under the theory, the gravitational theory. Okay, and what is the law? Gravitational law, you know, m1 m2 by r square. Okay, is proportional to m1 m2 by r square, and there is a gravitational constant. So this is what is a theory, gravitational theory, and the law, the relationship, and the hypothesis, and the testing, and fact, becoming a fact. So you will go through all this process during your research. You have proposed a hypothesis, you will repeatedly test several hypotheses and come to conclusions. Okay, so this is what we will be doing. And then, so we completed all these research stages, right? And then we finally come to collection of data. Collection of data, again, research for research methodology classes, it's different. But we will collect something different. But what is there in the syllabus is we have to discuss. But we will discuss something out of syllabus also. जो exam में नहीं आएगा. So collection of data. data collection is a systematic process of gathering information. So again, they say that you do it systematically, but definitely because of infrastructure or helplessness or randomly we do. Once you get, suppose for material science researchers, once you get a sample prepared, you have to find out that what is the sample, right? What is the composition of the sample and what is the structure of the sample? That is the for material science, that we do by X-ray diffraction, right? You know, all those. So we do an X-ray diffraction and find out, oh, okay, I have landed with first the dust sample is correct. My whatever I have targeted, I have landed up with the same sample. But what happens? Instrument down है, ये available नहीं है, या मेरे पास दूसरा FTI है, so I do that. So randomly, if you do, what will happen? This happened. So you will have already do, because of that problem, you have already collected a lot of other data, optical properties of the samples you have collected. Later on, you find that अरे एक स्टडी तो मैच ही नहीं हो रहा है, मेरा तो सैंपल बना ही नहीं, बट यू हैव ऑलरेडी स्पेंड टाइम ऑन कलेक्टिंग द डेटा for other things. But anyways, those things happen, but research methodology says no, that is not the way. You have to do it systematically. So it should be done systematic process of gathering information, numerical or non-numerical, from different sources to answer research questions. So whatever hypothesis you are targeting to prepare titanium dioxide, TiO2, you should get TiO2. So you start with titanium isopropoxide, you drop alkali and you get precipitation. So chemistry, everybody has done 12 practicals at least. So there what you do is it's iron salt you have and you precipitate with the help of sodium hydroxide or ammonium hydroxide. Sodium will create impurity, so you drop ammonium hydroxide and get iron hydroxide, right? And that iron hydroxide, it's a material you have got, and then you heat it, you get iron oxide. And that first you have to do is that you find out the X study and get come to know that it is iron oxide. Then I do the other studies. So this is what data collection is. Systematically we have to do. It is one of the most important steps in research methodology because the quality of your data determines the reliability and validity of research findings. Okay. So right now comes in that you have used sodium hydroxide, suppose, and I'm giving chemistry example, sorry, but but iron oxide, whatever you have got. So most important is because the quality of your data determines the reliability. Now you say I have got only iron oxide, iron oxide because the peaks, all the peaks are matching with iron oxide. But you carefully do a long-term X study, and sometimes you find that there are some sodium impurities still there. And then if you do a better quality, better XRD, very good XRD, you will be able to find out that is mismatch will be there. When you do an analytical analysis, you will find that okay, 0.1% or 2% of sodium is still there in my sample. Or if you have used some acid, or if you have used some chloride salt initially, iron chloride, instead of iron nitrate, you can find that some amount of nitrate, some amount of chloride is still present in my sample. So that is the impurity. So that data collection is very important. Your results will become reliable. Otherwise, what will happen? You are measuring the optical properties, but those it is coming because of those impurity present. It is affecting the sodium or chloride. What is present is affecting your data. Final optical property, suppose you are measuring of that iron oxide, that small amount of impurity. So you have to, your data will not be reliable in that case, isn't it? You will be reliable only if you do a proper characterization of that and find out, okay, मेरे sample में is only pure iron oxide and nothing else. Those I have to be careful. लेकिन हम क्या करते हैं, अरे दूसरा एक स्टडी ले लेते, कम टाइम में कोई पीक नहीं दिखेगा, and we said, देखिए, we write also it's pure iron oxide and we show that okay, that is you can do, but that will not be reliable. उसमें मजा नहीं आएगा. तो मजा आना है तो you have to be more reliable रहेगा, and then it will be valid for your research finding and it will be applicable to others. So this is one example I'm giving. Then in your research also in life science, physical science, such examples are unending. So that is why data collection is very important. But whatever is there in the syllabus, that is different, that will come. But ये मैं तुम लोगों को बता रहा हूँ, तुम जब डाटा कलेक्ट करोगे, ध्यान रखना कि एरर्स मिनिमाइज करें हम लोग। कैसे करेंगे? रिलायबल डाटा लेके। हाँ, रिपीटेशन करोगे तो टाइम लगेगा, अवेलेबिलिटी नहीं है, बट रिलायबल करोगे तो वो आ जाएगा। वी विल गो वेयर समवेयर we are getting a reliable result so that data is valid. What is the purpose of data collection? To obtain reliable information to solve a research problem. हाँ, ऑप्टिकल प्रॉपर्टीज अगर हमारा प्रॉब्लम है, सपोज my problem is to determine the luminescence property of f block elements, then I will be concerned with only luminescent properties. हाँ, हम लोग luminescence से फ्लू मीटर देखेंगे और उसी से हम लोग सॉल्व करेंगे। ऑप्टिकल प्रॉपर्टीज आर टॉट, राइट? केमिस्ट्री, हाँ, ऑप्टिकल इलेक्ट्रिकल प्रॉपर्टीज हो गया नहीं, अभी चल रहा है। हाँ, इनऑर्गेनिक केमिस्ट्री अभी नहीं, स्टिल नॉट। हाँ, कोऑर्डिनेशन चल रहा है। ओके, अच्छा, फर्स्ट कोऑर्डिनेशन चल रहा है। देन टू प्रोवाइड एविडेंस फॉर टेस्टिंग हाइपोथेसिस। सो डाटा कलेक्शन में क्या करोगे? जो प्रीवियस स्लाइड में दिखा है, इट इज द डाटा कलेक्शन इज डन टू टेस्ट योर हाइपोथेसिस। ओके, you are doing the data collection to test your hypothesis. Whatever hypothesis you proposed, you are doing the data collection for that. So that is definitely one of the purpose. This is in fact the first purpose. Then to solve the research problem, to support decision making, policy formulation, theoretical development, means finally theory develop करोगे तो उसको तो आएगा ही. To ensure results are accurate, unbiased, replicable. Okay, so that is why data collection is important. Types of data collection, they say there are two types of data collection broadly. Types, okay, primary data and secondary data. There are two types of data. Okay, primary data are those which are collected afresh for the first time and thus happen to be original in character. So when you are submitting a paper, they ask whether it is original. Original matlab you are doing it yourself for the first time. Okay, this is what is originality is meaning. So that is the this primary data collection you will do. You will do it yourself and for the first time. So that is what is meaning of original. But secondary data भी कर सकते हैं. Secondary data analysis करके you may do many things. वो हम लोग आएंगे क्या क्या. Secondary data on the other hand are those which have already been collected by someone else and which have already been passed through the statistical process. So secondary data has already been collected. Means review article लिख रहे हो तो क्या करोगे? Secondary data ही देखोगे ना. You will, the review article is not original. You are not creating any data and publishing it yourself. Okay, so this is what is secondary data and primary data. Collection of primary data. There was how you collect a primary data. There are several methods of collecting primary data. Okay, first is performing experiments, which most of you will do. Okay, maximum. Otherwise, instead of experiment, you do some theoretical research, computational research, like that. So depending upon the projects which you have. So performing experiments is the first point. Okay, ठीक है. And second, लेकिन ये था ही नहीं बुक में performing experiments because they are concerned with other type of research, because scientific research is not only the only research. There are, as I told you in the previous classes, sociology, psychology, so many subjects are there, healthcare, statistics. So in generalize they have done by observation method. Okay, so you are observing an experiment is also similar thing. Okay, so these are related. Other methods which are important which are related are interview method. ये सब है. Interview method through questionnaires, through schedules. So these are the other three methods, and the six are the other methods we have listed together. Distributor audits and all those for accounts and all those things. So these are the all primary data collection methods. But we will be performing experiments. Okay. Selection of method. Which method you will select? How it will depend on what you will, how you will select the method by which you will select do the data collection. It will depend on nature and scope and object of your inquiry. Okay, so what is the problem, what is your hypothesis related to that object of your inquiry? The data collection method will depend. Again, funds और time तो लिख ही देना, कोई क्वेश्चन आएगा तो. फंड अवेलेबिलिटी एंड टाइम लिखना ही है. फंड, एज आई टोल्ड यू, तुम्हारे केस में फंड अवेलेबिलिटी नहीं है क्योंकि तुम पैसा देके रिसर्च नहीं कर रहे हो. ओके, यू आर डूइंग एन इंस्टीट्यूशन, बट अगेन द funding of the institution will decide definitely, right? Because you are in institutional research where you are doing it, but here they are telling for individual. So if individual is doing a research, kitna funds hai, it will highly impact what type of data he can collect. उसके पास तो ओला लेके पैसा देके जाने का ही पैसा नहीं है, कितने बार जाएगा वो? तब वो स्टैटिस्टिक्स कर रहे हैं. ही विल, वी आर ऑल स्टडीइंग दैट वी विल कलेक्ट डाटा बाय क्वेश्चनियर्स. तो क्या करेगा वो? ऑनलाइन करेगा. अभी ऑनलाइन तुमको फोन आता है, हाँ, ऑनलाइन मेल आता है, डिलीट कर देते हो, हाँ, फोन को कट कर देते हो, अरे क्या कर रहा है ना. बट दे आर डूइंग इट फॉर रिसर्च पर्पज, एग्जिट पोल्स और वट एवर, फॉर सम रिसर्च पर्पज दे आर आस्किंग यू समथिंग, हाँ, फॉर सम प्रोडक्ट, इट माइट बी फ्रॉम सम प्रोडक्ट. तुमको, तुमने टिकट लिया या अमेजन में कुछ खरीदा है, कुछ प्रॉब्लम हुआ, सर अब तुमने सॉल्व कर दिया, आफ्टर दिस प्लीज गिव मी अ, हाँ, फीडबैक, ग्रेडिंग, वो कभी नहीं देते हैं लोग, हाँ, isn't it? So that is what is depending. So वो लोग क्या करेंगे, वो लोग ऐसे ऑनलाइन करेंगे एंड पीपल आर नॉट रिस्पॉन्डिंग. सो वेयर पीपल विल रिस्पॉन्ड, खुद जाके करना, उसके लिए यू नीड टाइम एंड मनी. So I'm talking about those kind of research. But here, your fund and time factor is not important, but not directly, but indirectly वो है, linked है. Indirectly it is linked. Okay, your funds. As I told you, somebody in a and some remote university is not getting access to advanced equipments which you will have, right, in a premier institution. So you will have access to so many equipments throughout. From you have heard Nordgate, you have heard Southgate, huh? सुना है? So between Nordgate to Southgate, so many equipments are there, huh? पता है कितना ACM है? मुझे पता नहीं ठीक से, but I heard that more than 30, huh? So there should not be any scarcity in getting the scanning electron microscope, हाँ. हाँ, ACM. तो तुमने क्या सुना? AC. अच्छा अच्छा अच्छा. सो 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 उस हिसाब से फंड्स के बारे में तुम्हें सोचना नहीं है, हाँ. हाँ? अरे मैं क्या बोल रहा हूँ, ऑनलाइन लोग क्या सुन रहे हैं मुझे पता नहीं. मैं सोचा ठीक ही बोल रहा हूँ. सो एनीवेज, सो you are rich, you can tell, rich researcher, huh? You have availability of good equipments indirectly, huh? And you will be doing advanced data collection. Time factor, you are also having time factor, huh? Time factor तुमको भी ध्यान देना है. I will not go into that some data collection which is taking more time. I will go for a more efficient way of data collecting where there is minimum time. And precision, जहाँ पे precision more हो, तुम्हारा objective क्या है, तुम क्या करना चाहते हो. जैसे एक सैंपल का ना, these are interview means, तुम लोग जैसे those who are doing material research, as you sit through your whatever means HBNI doctoral committee meetings, this will be asked, what is the difference you get between an SCM data, AFM data and TM data, क्या difference है तुम बताओ. तो there are so many differences from the source से लेके analysis of material में बहुत ज्यादा differences है. AFM में मुझे क्या डाटा इंफॉर्मेशन मिलता है, हाँ, एससीएम में क्या इंफॉर्मेशन मिल रहा है, टीएम में क्या इंफॉर्मेशन, वो भी डिफरेंट है. सो मैं क्या चाहता हूँ उसके ऊपर वो इक्विपमेंट मैं यूज करूंगा, क्योंकि SCM is, as I told you, is more easily available. TM is not so much easily available. Okay, so considering the time, if I don't need the TM, I can exclude that. Somebody who is doing the topography, ऊपर नीचे कितना है ये तुम्हें प्लेन लग रहा है, बट हाँ, माइक्रो स्केल में जाओगे तो इट विल नॉट बी अ प्लेन, देयर विल बी सम टोपोग्राफी. अगर प्लेन होगा उतना ज्यादा तो फ्रिक्शन नहीं रहेगा, विल फॉल डाउन, राइट. तो कितना, दिस इज अ परफेक्ट, कोई रिसर्च करे कि परफेक्ट वो जो इन होमोजेनिटी है कितना होना चाहिए, मींस द हाइट ऑफ दोज अप्स एंड डाउन्स, तो वो क्या है. सो उसके ऊपर रिसर्च करना है तो दे विल यूज एन एएफएम, हाँ, एटॉमिक फोर्स माइक्रोस्कोपी, विच इज बेस्ड ऑन अ कैंटिलीवर. हाँ, सो कैंटिलीवर प्रिंसिपल से वो लाइफ साइंस में भी यूज होता है प्रोबब्ली ना. हाँ, लाइफ, क्योंकि बायोलॉजी डिविजन में मैंने देखा है क्या होता है, आई डोंट नो. So this is how you will have to decide कि मैं कौन सा डाटा यूज करूं, हाँ. एंड व्हाट आर द की प्रिंसिपल्स. प्रिंसिपल्स क्या है, रेलिवेंट, मेरा डाटा रिलेवेंट होना चाहिए फ्रॉम माय हाइपोथेसिस पॉइंट ऑफ व्यू. जैसे somebody who is doing this topography, he will not do an ACM. ACM तुम्हें 2D पिक्चर देगा, उधर ऊपर नीचे भी देगा बट नॉट एक्यूरेटली. Then accuracy, data should be precise and free from bias. Reliability means consistent result. Reliability में जाओगे मतलब रिपीटेबिलिटी सेम होना चाहिए. वैलिडिटी, जो क्लेम कर रहे हो वो वैलिड होना चाहिए. टाइम मैनेजमेंट, फंड अवेलेबिलिटी तो डाल ही देना सब में, मैं बोल रहा हूँ. एंड एथिक्स, एथिक्स का पूरा अभी 15 क्लास करोगे, अभी तुम्हें कोई टेंशन नहीं है. तो एथिक्स के बारे में सब समझ जाओगे क्या है, हाँ. तो यू हैव टू डू एथिकली ऑल्सो द डाटा कलेक्शन. ओके, so that is beyond my purview. Okay. So examples, पहले साइंटिफिक एग्जांपल दिया, फिर सिलेबस का। ये सिलेबस में नहीं है, हाँ, ये क्वेश्चन नहीं है, एग्जाम में नहीं आएगा। सो तुम अभी बात कर सकते हो, या मोबाइल जो भी है। सो बट वो एग्रीकल्चर एग्जांपल देते हैं। फर्स्ट, डज ऑर्गेनिक फार्मिंग इंप्रूव क्रॉप यील्ड कंपेयर टू केमिकल फर्टिलाइजर? हाँ, ऑर्गेनिक फार्मिंग करने से क्रॉप यील्ड बढ़ेगा क्या केमिकल फर्टिलाइजर से? डेफिनेटली नो, लेकिन तुम्हें प्रूव करना पड़ेगा, क्योंकि इसीलिए तो ऑर्गेनिक का प्राइस ज्यादा है ना। ऑर्गेनिक के लिए पीपल आर गोइंग आफ्टर कि अरे फर्टिलाइजर पेस्टिसाइड्स ये नहीं रहेगा। सो प्राइमरी is what you have to do. Then definitely it will not be done in lab, right? You have to do field experiments. If you are doing such research, you have to go and do field experiment, measure plant height, grain, soil quality, farm surveys. Then you have to do farm surveys also. Farmer से बात भी करना पड़ेगा, जो लोग ये सब देखा है. That will give you quite. This is what this farmer survey जो हम लोग करते थे, एक्सपर्ट ओपिनियन है ना हर चीज में, हाइपोथेसिस में एक्सपर्ट ओपिनियन, प्रॉब्लम स्टेटमेंट में एक्सपर्ट ओपिनियन, हाँ, कुछ भी रिसर्च डिजाइन में एक्सपर्ट से बात करेंगे। सो दीज आर एक्सपर्ट ओपिनियन। जैसे तुम्हारे केस में गाइड्स अंडर डॉक्टरल कमिटी, एंड ऑल्सो यू कैन कंसल्ट अदर एक्सपर्ट एज वेल। सेकेंडरी डाटा, ये रिपोर्ट्स देखेंगे, हाँ, गवर्नमेंट रिपोर्ट्स एंड ऑल दोस थिंग्स। सो दिस इज अबाउट एग्रीकल्चरल रिसर्च। यू कैन एक्सटेंड इट टू हेल्थ केयर, impact of new diet plan on patients with type 2 diabetes. क्या होगा type 2 diabetes में? So as I told you, you have to have this measure blood sugar level weekly. मेरे घर पे से है, तो वो मेजर करते हैं, बट दैट इज वेरी कॉस्टली। हाँ, around what I will tell 7 times then just a fasting sugar. So depend, so fund availability important है ना, हाँ. So somebody who is having less fund, he will do just a fasting glucose which is much cheaper, repeatedly 7 days. But and HB1AC भी बार बार करने का जरूरत नहीं, because it's an average over probably 3 months ना, 3 months में एक बार करने से ही होगा. So which data you will collect, that you have to decide. हाँ, कि मैं HB1AC लूंगा वीकली, नहीं, वीकली हम लोग ऐसे ही लेंगे, 3 मंथ्स बाद हम लोग HB1AC लेंगे। तो तुम्हारे पास 5 सैंपल है, जिसके पास टीम है वो बोला मैं सिर्फ 2 सैंपल का कर सकता हूँ, हाँ, तो तुम यू हैव टू डिसाइड जुडिशियसली which 2 samples are important, which you will give, so that whatever you are claiming in your results is coming from that 2 or 3 samples which he is willing to do. ऐसा नहीं है इधर कोऑपरेट लोग है सभी कर देगा, लेकिन इमीडिएटली बोला कि मुझे 2 वीक में यही कर पाऊंगा, 1 महीने में मैं 5 करूंगा. सो लाइक दैट यू हैव टू compromise. That decision you have to make. So psychology, does regular mindfulness meditation reduce stress level in college students? स्ट्रेस क्वेश्चनियर्स तुम्हें देखना पड़ेगा, साइकोलॉजी मेजरमेंट्स करना पड़ेगा, जैसे वो हार्ट रेट, कॉर्टिसोल लेवल्स, हाँ, हम लोग बोल रहे थे कॉर्टिसोल लेवल मेजर करेंगे. सो दोज आर क्वांटिटेटिव. सेकेंडरी में हम लोग पास्ट लेवल, पास्ट कोर्स देखेंगे कि क्या क्या है. सो दिस इज हाउ वी गो अबाउट. देन केमिस्ट्री में आते हैं. So what is the catalytic efficiency of a novel synthesized metal organic framework for CO2 absorption? So as we discussed, so metal organic frameworks, these are porous materials. Okay, so these are frameworks, porous materials, उसमें गैस एब्जॉर्ब होता है, गैस, कोई भी गैस फेज में जो स्पेसिफिकली यू कैन एब्जॉर्ब. तो CO2 क्यों करेंगे? जो CO2 इज अ पोल्यूटेंट, राइट. हम CO2 एयर में है, लेकिन CO2 बढ़ रहा है, पोल्यूशन आ रहा है फ्रॉम द फॉसिल फ्यूल और द कोल, जहां जहां से पोल्यूशन आ रहा है. तो सपोज कोल फैक्ट्री में हमें एक ऐसा एब्जॉर्बेंट लगाना चाहिए जो CO2 निकल रहा है वो एटमोस्फेयर में ना आ जाए, बिकॉज देर इज समथिंग कॉल्ड नेट जीरो, है ना. एज आई टोल्ड यू, 2070 इंडिया विल अचीव नेट जीरो CO2 emissions. मीन्स जितना, हाँ, तो कैसे करेंगे? तो दिस इज एन इम्पोर्टेंट रिसर्च. तो इसमें अगर रिसर्च करना है कि केमिस्ट्री या फिजिक्स, बोथ इट इज पॉसिबल. सो व्हाट डाटा यू विल डू if you design a noble metal metal organic framework. So its pore size is such that it can absorb a lot of CO2, and इंटरेक्शन बढ़ाने के लिए मेटल को वैसे सिलेक्ट किया कि CO2 के साथ इंटरेक्ट कर जाए और वो अंदर घुसता जाए, हाँ, और एब्जॉर्ब कर लो तुम बहुत. तो तुम क्या करोगे? सिर्फ एक्सपेरिमेंटल डाटा ऑन CO2 अपटेक, कितना CO2 अपटेक कर रहा है वो देखोगे, डेफिनेटली दैट वी विल सी. हाँ, बट उसके सिवा तुम्हें अगर उस डाटा को, सपोज यू वांट टू प्रेजेंट दैट डाटा, दैट ओके दिस काइंड ऑफ मॉफ्स आर गुड एज अ CO2 एब्जॉर्बेंट, इन जनरल तुम्हें क्लेम करना है, तो मॉफ के बारे में तुम्हें सब कुछ बताना पड़ेगा. यू हैव टू टेल एवरीथिंग अबाउट द मॉफ. सो यू हैव टू वेल कैरेक्टराइज द मॉफ. हाउ विल डू? एज आई टोल्ड यू, फर्स्ट यू विल डू द XRD, ओके, टू फाइंड आउट की फेज क्या है. for chemist people. And then IR, then BET surface area से नाइट्रोजन एड्सॉर्प्शन डिसॉर्प्शन करते हैं. सबको नहीं area की कैसे, and from there how is the pore size distribution. These mobs are porous, pore size distribution कैसा है हमें पता चलता है. Not exactly nitrogen BT, but nitrogen adsorption desorption. And these are other SAX, small angle X-ray scattering, is a method by which you can do pore size measurements also. Okay, and these two are related. And then specific to Department of Atomic Energy or DRC, you have one technique known as positron annihilation lifetime spectroscopy. Positron पढ़ा है कोई? Physics लोगों को पता है, everybody. So positron annihilation lifetime spectroscopy. So positron annihilates within the holes, and it helps you to give this PALS techniques helps you to give idea of the pore size. Okay, then you do an XPS. What you do in XPS? X-ray photoelectron spectroscopy. Which is true for biology. So people also do chemistry as well as physics. The X-ray photoelectron spectroscopy gives you the surface, chemical composition, and the oxidation state of that. And those oxidation state and these peaks, means whatever the X-ray photoelectron spectra से तुम्हें जो मिलेगा, each chemical identity is also released. Means each element, how it is standing, how the chemical environment around that element will affect that. तो तुम chemical environment बोल सकते हो surface पे कि वो किस position पे है, उसका कौन सा ऑक्सीडेशन स्टेट में है. ऑक्सीडेशन स्टेट अगर कोई इलेक्ट्रॉन डेंसिटी ले लिया तो बाइंडिंग एनर्जी, वी जनरली प्लॉट बाइंडिंग एनर्जी वर्सेस इंटेंसिटी. Suppose the electron cloud from, suppose you are measuring the, what I will say, the oxidation state of cobalt. Cobalt is in 2+ state. उसका एक electron cloud है 2+ का. But some neighboring atom has taken the electron cloud away more. Then it will go towards a shift, not to 3+, but higher than 2+ you will get. The binding energy will increase. There will be a decrease if there is a lesser electronegative atom, which gives you this. Gives some electron cloud towards CO2+. So 2+ से थोड़ा कम में आएगा. So all those effects you can see by XPS. Then SEM, TEM will give you idea about the morphology, the surface, the features on the surface. Okay, and then ZANES and EXAF will give you idea about the local structure. कहाँ पे उस एक एटम के बाजू में कैसा है चारों तरफ, उसका कोऑर्डिनेशन क्या है. Like octahedral coordination you heard, right? BaTiO3, बेरियम टाइटेनेट में पढ़ा है. बेरियम टाइटेनेट अभी तक नहीं आया ना. अच्छा, कोऑर्डिनेशन चल रहा है. So around टाइटेनियम टाइटेनिया Ti के बाजू में 6 ऑक्सीजन आयंस है. Ti4+ and 6 octahedrally arranged. एक प्लेन में 4 है, ऊपर नीचे 1 है. So if there is a shift, all those things you can find. अगर octahedral distorted हो गया, all those things you can find by all these techniques. So you have to do such data collection in chemistry and arrive at the conclusion. And then experimental data ले सकते. और क्या कर सकते कि क्या हो रहा है, CO2 डालने से क्यों वो CO2 ले रहा है. You have to find an answer, right? So what you will do, then you have to go to the mechanism. For that you have to do in situ spectroscopy, right? In situ means CO2 डाल के तब उसमें क्या चेंज हो रहा है वो देखना पड़ेगा. When CO2 is there inside. So you have special cells. There is RRCat where there are in situ EXAF spectroscopy available, where you can go and do in situ spectra. There are in situ FTR, in situ Raman facilities, various places in India. Then finally कुछ समझ में नहीं आ रहा है, then you go have to do a theoretical understanding कि वो डिजाइन करेंगे theoretically, हम नहीं कर पाएंगे तो किसी से कोलैबोरेट करेंगे. एंड देन वी हैव टू फाइंड आउट कि क्या हो रहा है मेरे मटेरियल में CO2 डालने से कि इतना CO2 ले रहा है. ये 5 मटेरियल बना, 5 मेटल ऑर्गेनिक फ्रेमवर्क्स where the metal concentration or the organic type you are changing, one of the functional group you are changing, उसमें क्या इफेक्ट हो रहा है. Then these are the data collection, all these things you have to know. Then only you can test your hypothesis and come to a conclusion. And you do for 4-5 system, it becomes a fact and you present your thesis. इतना ही करना पड़ेगा. And material science example means material science क्यों बोला, because कि ये chemistry, but actually material science, chemistry, physics, there is not much boundary. Life science there is a hardcore boundary, but physics, chemistry, they are almost intermixed. So in material science, it comes under physics and chemistry also. How does doping graphene with nitrogen affect its electrical performance fuel cells? So I told you fuel cell is a device which converts a fuel into electricity. So fuel can be hydrogen or alcohol. One day we talked about direct alcohol fuel cell, right? So those fuel cells, you need a catalyst. So this is the catalyst, graphene, nitrogen broke graphene. Graphene is the material which has got नोबेल प्राइज भी मिला है उसको, है ना, यू डोंट नो, पता नहीं, अच्छा उसके बारे में तो मेथोडोलॉजी में नहीं है, ये भी नहीं है, ये एक्स्ट्रा बोल रहा है. So here also you have to characterize by all these techniques. You have the scope, right? This is the scope कि नाइट्रोजन डोप करने से क्या हो रहा है उस स्ट्रक्चर में, पूरा स्ट्रक्चर में अराउंड द कार्बन एटम्स, कोऑर्डिनेशन उसका कैसे चेंज हो रहा है, एंड देन हाउ इट इज अफेक्टिंग. Here you were the effect. See, this dependent variable was different, CO2 absorption. But here the dependent variable you are changing, fuel cell का performance. हाँ, तो हमें उसको इलेक्ट्रोकेमिकल टेस्ट में सब्जेक्ट करना पड़ेगा. So we will do in an electrochemical cell all these measurements like CV, cyclic voltammetry, linear sweep voltammetry, impedance spectroscopy, chronoamperometry will do, and then correlate with these data, structural data, and then find out the structure property correlation. यही मैं जो बोल के आ रहा हूँ ना, structure property correlation, तो वो structure हमें मिल जाएगा, वो property के साथ correlate करेंगे. हाँ, ये जो पार्ट है स्ट्रक्चर वाला पार्ट, डिटर्मिनेशन, वो मॉफ हो या ग्राफीन हो या कुछ और हो, कोई सीएनटी में काम कर रहा है, somebody is doing anything else, ये सिमिलर है ये कैरेक्टराइजेशन. बट सिर्फ ये टेस्टिंग, इधर इलेक्ट्रोकेमिकल टेस्टिंग है, इधर CO2 अपटेक है, कोई कैटालिसिस कर रहा है, वो कैटालिसिस टेस्टिंग है, ये डिफरेंट होगा. सो डोंट बी सो क्रिटिकल अबाउट योर प्रोजेक्ट्स, ये नहीं होगा, तो ऑलमोस्ट सिमिलर काम ही करने वाले हो, है ना. एंड इट डिपेंड्स हाउ यू डू दिस डेटा कलेक्शन, हाउ नाइसली you correlate the data. Then here also you can do in situ spectroscopy and also theoretical understanding. And additionally here what you can do, you can devise a fuel cell, एक fuel cell design कर सकते हो. fuel cell design करके उसमें तुम्हारा catalyst run कर सकते हो fuel cell mode में. Instead of just testing your material, you can go into device mode. So that will be, once you make a device, it becomes interesting or applicable. You show a demonstration in your thesis, so the examiner will be impressed. एक device भी बना के दिया है at the end. So we come back to syllabus. अभी फिर से syllabus में आ गया है. अरे अभी बात बंद कर दो, अभी देख लो. Now again coming back to syllabus. So here how to collect the primary data. So ये सब बहुत कुछ लिख के आया हुआ है. So collection of data through questionnaire. This is the first technique. So हम लोगों ने क्या क्या देखा है? So what are the techniques? So several methods of collecting primary data. That is performing experiments, observation method, interview method, through questionnaire, through schedule. So we are doing number 4 through questionnaires. How we will do it through questionnaires. Okay. So this method of data collection is quite popular, particularly in case of big inquiries. It is being adopted by private individuals. तो मैं जो बोल रहा था, privately भी लोग PhD कर रहे हैं. research workers, sorry मैं इधर क्यों डाल रहा हूँ, private individual, research worker, private and public organization, even by governments. Governments भी कर सकते हैं ऐसा, government करते हैं basically. They do such type of questionnaire and find out कि उसका जो implement, जैसे MNREGA जो policies implement कर रहे हैं वो कैसे feedback लेते हैं. They do a research on that. So this is the agencies who will do. So private individuals, research workers, private and public organization, even by governments. The merits claimed on this behalf, these are the merits. There is low cost even when universe is large and is widely spread geographically. So you can do all over India में कर सकता हूँ मैं, है ना, questionnaires. Question में all over India में डाल सकता हूँ. So it will be universal. It is free from bias of interviewer. Answers are respondents' own words. सिर्फ question करोगे, ऐसा नहीं बोलोगे हाँ या ना, नहीं बोलो. Questionnaires कर रहे हैं. So मैं बायस नहीं कर रहा हूँ, जो रेस्पोंडेंट होगा दैट उसका थॉट प्रोसेस आएगा इनमें. ही कैन प्रोजेक्ट अ न्यू पॉलिसी आल्सो, मींस propose. Respondents have adequate time to give well thought out answers. Responses are not easily approachable, can also be reached conveniently. Large sample can be made use of, and thus results can be made more dependable and reliable. Demerits क्या है? Low rate of return of duly filled questionnaires. कोई तुम लोग भर के नहीं देते हो, है ना. And it can be used only when responses are educated and cooperating. Cooperate करो. The control over question may be lost once it is sent. There is an inbuilt inflexibility in difficulty amending the approach and other things. So I have listed all those कि ये रीडिंग पढ़ने से तुम देख लो इसको कि हाउ द कलेक्शन ऑफ डेटा आर डन थ्रू क्वेश्चन. क्या 3:35 हो गया? तो इधर ही हम लोग बंद कर देते आज. हाँ हाँ